Hello everyone, my name is Austin Shaner, and welcome back to my channel. In the last video, we took on one of the most challenging parts of guitar machining, flat guitar necks. However, in the world of guitar machining, there's yet another final boss, an order of magnitude more difficult: necks with angled headstocks. Angled necks are probably the #1 thing that intimidates people about building guitars with CNC. And for good reason. It has a very complicated shape. It requires precision in your glue-ups and even more complicated toolpaths and work holding. Not to mention that there's no single or even two-sided setup where all these features are accessible. We're dealing with a 3-sided machining monster. So I spent the last few months thinking about the best ways the average person at home could take on such a project. I came up with almost 100 different methods, but each had serious limitations that essentially forced you to choose which part of the process you want to make difficult for yourself. Well, frustrated with my options and about ready to give up, I took to Discord to get viewer opinions on the ideas that I was working with. I was gently reminded by one of my viewers that I might be approaching this the wrong way, that I shouldn't be thinking necessarily about how to work around the problem or finding the cheapest or fastest way to do this. I should be developing a repeatable process for the guitar community, regardless of complexity. And then, once I have a repeatable process, finding ways to make it more streamlined and accessible to the public. This changed my frame of mind, as after all, I am a process tech by trade. Process techs develop safe and repeatable manufacturing processes that ensure quality by mitigating the chance of human error. So, if I put on my process tech cap, how would this change my approach? Well, that is precisely what I would like to show you. I believe I have managed to develop a low-cost solution that should be achievable on nearly all desktop CNCs, even those with limited Z clearance, using nothing but a sheet of plywood, 3D printer, and some clever work holding to simplify and error-proof my order of operations. So let's not waste any more time, and let me show you. So jumping into Fusion, let's quickly talk about what makes an angled headstock neck unique compared to a flat headstock neck and why it's so much more difficult to machine. And then we'll go into what the method looks like. So if we take a look at this neck right here, you can see that we have a perpendicular surface to my fixture right here, which means from this angle, we have access to these holes, this face, and the outer contour, but we don't have access to the rest of the neck, right? Especially, you might be able to if you have enough Z clearance on your CNC, but if you don't, then basically you're stuck with just machining this little section. In fact, here's an easier way to show you. So if I hide my CNC, and let's hide my fixture, and just bring up my neck. And if we go into the manufacturing workspace, there's a really cool tool in here that many of you may not know about. So if you go to Inspect, there's Accebility Analysis. And what this does is it lets you effectively see what part of your model is machinable with a flat cutter from any given direction. So I selected my model, and so if I'm looking at my model from this direction, everything that's green here is machinable. But if I even tilt it a little bit this way, you can see that these sidewalls and these tuner holes aren't accessible, and this backside's not accessible. And so then I can flip the direction, and I can see, well, if I'm machining it from this side, all of this is accessible, except if I turn it this way, all of a sudden you can see that part of my headstock transition and my tuner holes aren't accessible either. And so that means that really, those two setups, I can't hit all of the critical dimensions that I need to hit. So there's actually a third setup that actually has access to just about everything, but it presents a really big challenge for your CNC. So let me see if I can rotate this real quick. I think I have it on fixed. Let's go to free orbit. There we go. So if I mount my neck like this, right, then I have access to basically that entire top contour of the neck. The challenge is that raises my neck up at a very extreme angle and really high up on my CNC, and I don't have the clearance for that. So that effectively means that what we need to do is we need to both machine it from this side and then we need to machine it from this side. And then we also need to machine it whatever we can from this angle to clean it up. So that's a really tall order, and that means that our work holding has to get pretty elaborate. But there's also one additional thing that makes a angled neck much more difficult than a straight neck, and that is a scarf joint. So most of you watching this are probably familiar with a scarf joint, but just in case you aren't, essentially what you do is you take your blank and you slice it at an angle and separate it into two pieces. And then what you do is you actually take this piece and you flip it 180 and then glue it together like this. And what that does effectively is it allows the long grain in the neck to extend most of the way up the neck, but then it switches the angle of the long grain of the neck to follow the actual neck break angle. And the point of that is if you built this out of a single piece of wood, what you'd end up with is short grain on this front face. And that makes it particularly weak under string tension, and it's very easy to snap your neck at that point. So that's also something that we have to take into consideration. So we can either do this manually by ourselves in our home shop, or we could actually find creative ways to let our CNC do it for us. And so now that we've kind of got this out of the way, let me show you guys the method that I put together. All right, here's the game plan, folks. First thing we're going to do is we're going to rough trim our stock on the table saw and bring it down to the correct thickness, either with a facing operation on our CNC or with a thickness planer if you happen to have one. Then we will place our fixture on the CNC and insert 4 dowel pins to align it with the machine. Then we're going to place our rough stock over the left side of the boundary with double-sided tape. This will allow us to bore out the tuner holes and dowel pin holes that will be used for alignment throughout the rest of the process. Then we will cut our outer contour so that we have a perfectly dimensioned blank to help us a lot when aligning the part for glue up. Now we can take the blank off of our CNC and split the part in two with either a pull saw or a bandsaw, making sure to stay within a fairly generous safe zone. Now it's important to remember to stay as close to center as possible during this cut, as any remaining stock on either side of your saw curve will effectively be our stock to leave in the next operation. Then we will place 2 dowel pins into the fixture and place the headstock side of our blank onto the fixture with double-sided tape. Then we will be able to do a scallop operation with a ball nose end mill to true up the rough cut surface and leave us with a nice scarf joint at the appropriate angle. Then we will take that off and do the same thing for the heel side of the neck. Now we can take both parts off the CNC and clamp them together without glue and drill 2 dowel pin holes through both pieces so that we can realign them once we apply the glue. Now it's really important to take your time and get these as perfectly aligned as possible before you drill your holes, because any mistake here can cause alignment issues later on. Then, once the holes are drilled, we will unclamp the parts, apply our glue, put them back together, and then insert 2 dowel pins into our holes, clamp them together, and let the glue set. Once the glue is set, we can now move our dowel pins on the fixture up 1 row and place the assembled blank on the fixture with the headstock hanging off the front of the machine. This will allow us to mill out the truss rod slot and potentially face off the fretboard side in case there was any misalignment during the glue up. The scarf joint and the fretboard side should now be complete. Now that we have the front side complete, we will insert 2 dowel pins into the right side of the fixture and install the blank truss side down with double-sided tape. Then we will slide our 3D printed wedge up to the headstock and secure it down with 2 shoulder bolts. These both serve as dowel pins and allow us to secure the part to the wedge at an angle. Then we will tighten down the wedge to the fixture. The slots in our wedge allow us to accommodate any variation in the angle that may have happened during glue up. Then we will do our primary contour, roughing, and finishing strategies on the main portion of the neck and up to the headstock transition. Then we will take that blank off one last time, flip it over, and secure it headstock down to the same 3D printed wedge and fixture. This will allow us to do our final contour, roughing, and finishing on the back side of the headstock, making sure to clean up any remaining stock on the transition that we didn't have access to when it was flat. This should leave us with a finished guitar neck ready to sand and apply finish. Okay, so jumping into the manufacturing workspace, let's go ahead and get this started. So I created a folder structure here called Angled Neck Setup in my models. and I created two components under that called Stocks and Operations and Fixture. So obviously in Fixture, I have my primary fixture here as well as my 3D print and any various hardware that I might need. And then in the Stocks and Operations, I created basically a folder structure for each individual orientation that we're going to need to machine this model in. And the point of that is because unlike my previous videos where I had the model be the central piece and then I had a fixture that rotated to either side of the model depending on how we flipped our part, we have enough unique orientations here that it was actually just simpler to create different stocks for each operation or orientation and then just copy our body over. And so in here, we'll go through these one by one and then we'll start programming the cam. So I have my pre-split operations. So in here, I have my raw stock, which I will face off and drill the tuner holes, etc. And then I have my split stock, as you can see here, where I've basically got my scarf joint. Now, obviously, we won't be machining the scarf here, but this allowed me to generate my raw stock and create this gap here that we will need for machining it later. So we actually had to split basically our model in two and separate it by a couple of inches so that way we could actually have room to saw our scarf joint without actually cutting into our model. And then after that, I have my scarf surfacing. So if I bring this up, in here, let's go to bodies. Oh, I'm in fixture. That's why. In here, I have two models. So I have my headstock side, and then I have my heel side. And pretty straightforward. We're going to use those as our stocks to go ahead and machine. And then I have operation number 3, which I'm calling truss slot overhang. And in here, I have my two stocks that overhang. And I also have my model set up in this orientation, so that way I can use that to select geometry for cutting out the truss rod slot. And then in operation number 4, let's hide these real quick. And in operation number 4, I have my two stocks here that I used to actually generate a third stock. So I was able to get my angle from that, but then I created a single piece body, because sometimes what Fusion does is if you're selecting two bodies at the same time for your stock, it can throw errors with Z clearance later on. And that became a big problem when I was developing this. So I just used these two stocks to generate a single body for me. And that's the body we'll be using for our stock. And then we can go ahead and hide this. And then operation number 5 is we have it up at an angle. And I kind of did the same thing where I generated another third stock, but I ended up not using that, and I will actually explain why later. But essentially what this let me do, and I have the model here as well, although it's kind of hard to tell. That way we can select the geometry. But effectively what this allowed me to do was have one fixture and then just orient my part in all the different various orientations. And so that way I can make sure everything fits as we go through my order of operations. So let's go ahead and close this out. And we're going to go ahead and create our first setup for the pre-split. So let's hide this. And let's actually we need to bring that back, and we'll bring up pre-split. And let's hide these two and bring up our raw stock. So let's create a new setup. And in here, let's go ahead and select our model as our stock, because we don't actually need the guitar in here because we modeled in the dowel pinholes and the tuner holes into the stock itself. So that's actually going to be both our model and our stock. And then we'll say our work offset is selected point, this front left corner of the fixture. And if you're wondering why I do that, go ahead and go back and watch my guitar bodies video where I go into that quite in great detail. And then we will select our X and Y axes here and here. And then we will flip our X. So that way we have our X going in this direction, our Y in this direction, and our Z going up. And then our fixture we will go ahead and select this body right here. And then in the stock selection, we're going to say from solid, and we're going to choose the same model. And then hit OK. And now we've got our first setup. So let's hide this for now. And then let's go ahead and do the dowel pinholes. So that's going to be the first things first. We're going to go ahead and take care of the dowel pinholes. So we'll go 2D boring operation. And then we will select our end mill. And for this, we're going to use a 1/4 inch flat end mill. Hit OK. I've already got my feeds and speeds set up. And then we will go to geometry. We will select all of our dowel pinholes, but not the tuner holes, because the tuner holes are 10 millimeters and I'm using 3/8 dowel pinholes because that's more readily available for me here in the States. And then I can go to heights, and we want to make sure the bottom height selection goes down to the fixture. And then we will go negative. We'll just make sure it goes down below just a little bit. So we'll go negative 0.03125. So it goes slightly below the surface. So we're good there. Top heights, looks like we can keep them the same. Let's just go ahead and make sure that, yes, top height is from whole top, so we're good there. Passes, we don't need any multiple passes. We do want some stock to leave though, because we want to get these dead on accurate. So this is basically going to be a roughing pass. So we'll leave 20 thousandths of an inch as stock to leave. Okay, and while we're here, let's go ahead and do the roughing for the tuner holes. So let's go 2D boring operation. In fact, you know what? Let's right click this, and then we'll say create derived operation, 2D milling, boring. And what that's going to do is it's going to retain all of our previous selections, and we're just going to change our holes. So then we will come to the geometry tab, unselect those, and then select our tuner holes instead. And let's just go ahead and make sure that our heights are set up correctly. Yes, they are. Go to our passes. Yes, we have stock to leave. Okay, we are good. Now what we want to do is come back in and do a finishing pass on this that we will sneak up on the dimensions, so that way our dowel pins fit perfectly. They're not too tight and they're not too loose either. They just kind of glide in. So let's do another boring operation. So what we're going to do is we're going to right click this one, create derived operation, another boring operation. And in this case, we're going to go to the passes, and what you're going to end up doing is you're going to save this as a separate operation, and then you will run it, and what you'll end up doing is you'll say, okay, instead of 20 thousandths, we're going to leave 10 thousandths. Run it real quick, test your fit, and then if that's still too small, maybe take 5 thousandths. And then if you go all the way to 0 and it still doesn't fit, you can actually go negative 0.005, and it will actually expand the hole for you a little bit. So we're going to go ahead and just leave this as 0.020 for now. And let's go ahead and name these real quick. So we've got dowel pin roughing, tuner hole roughing, and dowel pin sizing. And then we're going to do the same thing. We're going to go, in fact, we can just duplicate this instead of create derived operation. And then that way we can come back in and change the stock to leave and fine tune that fit. And then the last thing we need to do is we need to create a 2D contour on the outside perimeter of the part. And the purpose of that, even though we've put a pretty decent size stock on here, is we want to trim it so that it's exactly the same on all sides, because that's going to give you a really nice clean surface to reference off of when you're gluing this up for the scarf joint. So let's go 2D contour, and we still have our 1/4 inch flat. We're good there. In the geometry tab, let's select this outer contour, and then in the heights tab, we're going to go down to selection, this bottom face. Top height is stock top, so we're good there. Everything else should be fine. And then depending on what your CNC is capable of, you can either take it in one pass or multiple passes. I personally like to take pretty conservative cuts when I'm plunging through the material. So I'm going to go 0.0625 inch step down. And that should be good. We don't need any tabs because we're going to be using double-sided tape to hold this part down. Okay, and let's simulate the whole thing. And like always, I'm going to be using comparison view, although in this case it doesn't make a whole lot of sense because we actually are stock and everything is the same. So we're going to, ooh, that is going too fast. It says tool collides with fixture, but that's only because I'm going down below the surface. That's okay. So we're going to do our dowel pin holes, the rough sizing of them. Then we're going to do our tuner holes. And then we're going to come back in and resize all of those. And then do our contour. Okay, that looks good to me. So now we can move on to the next setup. And let's name this setup Stock Prep. And so let's go ahead and create a new setup. And before we select anything, let's go ahead and make sure in our angled neck setup folder that we turn off pre-split and we go to scarf surfacing. So in between these two setups, you will then have pulled off your blank and sliced it. And then now we're going to put it back on the CNC and go ahead and surface our scarf joint. So let's go ahead and pull this up and let's go ahead and do the headstock side first. So let's say our model is this and our stock is this as well. And then our work offset, well, let's do our fixture here. And then our work offset is selected point. Same thing as before. Select XY axes here and here. Flip X. Everything looks good. Hit OK. And now what we can do is we can come in and do a 3D scallop because we've already got stock to leave on here from cutting these apart. So all we need to do is come in with a ball nose end mill and clean it up. So let's do a scallop operation. And the reason I'm choosing scallop rather than a parallel or ramp or anything like that is we've got a very, very thin edge down here at this front side. So we need to make sure that when we mill that, it has as much material around it as possible so we avoid any kind of tear out or anything like that. So what's nice about a scallop is that it kind of works from the outside in. So when it cuts this edge, it has as much material around it as possible at that point. So it'll be as strong as we can possibly make it. So let's go to geometry, and then we will say our tool machining boundary is selection. And let's select this contour right here. And we can say the tool can go outside the boundary. Actually, no, let's just go ahead and do on center. And then let's do contact point boundary, so that way it can go slightly over the edge if it needs to. And let's make sure we have a ball end mill selected. So under tool, select, and then we'll go find a 1/4 inch ball end mill, or whatever size ball end mill you're going to be using. Looks like I don't have my feeds and speeds set up here, so I'm going to do 16,000 RPM, and we will do 75 inches per minute. That's a pretty decent chip load. We're also going to be taking really small little passes, so we could probably be more aggressive with this, but that's okay. And then our bottom height is model bottom. That'll work for us, or we can do selection down to the fixture. And then we can say passes. We don't need any stock to leave. We just need to make sure our step over is very fine. So we'll go a 32nd of an inch. You can make it smaller or larger depending on the size of bit you're using. Since I'm using a 1/4 inch bit, a 32nd seems to leave a pretty nice surface finish. So let's go ahead and hit OK. Oop, I didn't turn off coolant. So let's go back to the tool library, or not tool library, the tool tab, and disable that and hit OK. It's going to take a second to generate. And let's simulate that real quick. Again, it's not going to show the stock here because we selected the stock and our model as the same thing. Really what we just want to see here is the toolpath and make sure it's doing what we want it to do. So let's show our toolpath here. Okay, and yes, it is coming up on that boundary there. Let's see what it does on this front edge. Speed this up just a little bit. Okay, yep, it's just touching that front edge, but it's not having to roll over. I put this little channel in here just in case I needed it to roll over, but that's okay, we don't need it. So let's speed this up a little bit now. And it works its way in, surfacing that whole top face, and now we have a very nicely dimensioned blank that we can just kind of sand very lightly to get any of those cusps off, so that way we have a nice glue surface. So what we're going to do now is we're just going to duplicate that and then change our setup to be the other model. And let's name this real quick. Let's go ahead and name this Scarf Headstock. And then let's duplicate. And then in here we need to edit our setup. And we need to hide our headstock scarf and show our heel scarf. So now we just need to change our model to here, and then go to our stock and change our stock to that as well. Our work coordinate system is already set up for us, and our fixture is already set up, so that should be good to go. Now we just need to update the toolpath, because right now it still thinks that toolpath is on the other one. So let's right click that and go edit. And then we're just going to change our machining boundary and hit OK. And now we have the exact same toolpath, but set up on the other side. And real quick before we move on, let's rename that as well to Scarf Heel. Okay, and now let's go ahead and create a new setup. And inside that setup, we need to hide scarf surfacing because we're no longer using that. And now we're moving on to truss slot overhang. So let's show that real quick. And let's hide our stocks for a second, and this time we're actually going to be using our actual guitar neck as our model. So we'll go ahead and select that, because now we have geometry on the neck that we need to select, like the truss rod slot. And then let's go ahead and set our work coordinate system. So same thing as before, selected point, select XY axes here and here, and then flip our X. And then on fixture, we'll go ahead and select our body there. And then in stock, we're going to go from solid. And in this case, what I'm going to do is I'm going to use both of these models as my stock. Like that. In this case, that works. What doesn't work is when you flip the body over, because then your stock, it has to basically create a boundary box that's higher than the parts you want to machine. Since it's in this orientation, the boundary box extends below the machine, so it doesn't really matter to Fusion that you have two bodies selected. But it just does matter when, let's say, when you're in this orientation, and now all of a sudden it thinks the top of the model is over here, whereas in this case it knows the top of the model is where we want to machine anyway. So doing it this way is not a problem in this instance, but we will get more into that later. So let's go ahead and hit OK. And let's hide our stocks. So we only are dealing with the model. And let's go to 2D pocket. So 2D pocket. And we're going to do this one by itself first, because we're going to end up doing a stock to leave on it. And then we will come back in and do the others, and then one to clean that up. So that's going to be our selected geometry, is that bottom face. In this case, we need to switch to an 1/8 inch end mill, because the distance here between these two is 0.2188, so it's smaller than my 1/4 inch. So this is the only time I'm going to be using an 1/8 inch end mill. So let's close that out, tool library, and we'll go to 1/8 inch end mill, 16,000 RPM, and I'll be a little bit more conservative here. Let's go ahead and say 50 inches per minute. And then geometry, we're already good there. Heights, let's say it's already set to selected contours, but I like to forcibly, let's say, select it down so I know that I'm going down to the right height. Top heights from stock top, so we are good there. And then passes, we're going to do multiple depths, and I'm going to go down 1/16 of an inch at a time. And we want to leave a little bit of stock to leave, but we only want to leave it on the side walls. We don't want to leave it on the floor. So we're going to take axial off to 0 and just leave 20 thou of radial stock to leave. And we will say, we'll allow the cutter to cut in both directions. And then our maximum step over is going to be less than half the bit. So we're going to go 0.06. That should be good. So let's go ahead and see. I need to turn off coolant again. So disabled and hit OK. So that should be good. And now we can move on to the pockets for the other ones. So let's go 2D pocket. And then we will go the same 1/4 inch flat. It's already got our settings, so we're good there. And we will just go ahead and select both of these because it will be able to accommodate for the depth. And then we're going to leave it as selected contours in this case because that way I'm not only going to one depth, I'm going to whatever depths that I had selected. And then in passes, we're not going to leave any stock to leave at all, but we will do multiple depths of 0.065. And our maximum step over will be 0.06, so a little bit less than half the bit. And we will allow it to go both ways. And let's turn off lead ins and lead outs. We just kind of want it to plunge going in, and we will set our entry positions as right here. That way our bit's not going to try to plunge in outside the model or into the model. We're going to try to make it plunge right here. Hit OK. That's looking pretty good. And then let's go ahead and do a cleanup pass on this, and then we'll simulate this as well. So let's go create derived operation, 2D milling, 2D contour. And we've already got our settings, so we're good there. And we've already got our chain selected, so because we did a derived operation, so we're good there. Heights, it's already going down to that selection. In this case, we want to take off multiple depths, and we don't want any stock to leave. And that looks good. So let's go ahead and let's simulate this. Now, just like we did with the dowel pins and the tuner holes, we're going to sneak up on that with this operation. So make sure to save that as a separate operation on your computer. So that way you can take a little bit more off and a little bit more off, etc. So let's just go ahead and simulate that whole thing. Now we can actually see the blue and green because we actually have a stock that's larger than our model. So it's milling out this side, or not this side, the truss rod. Let's look at it down a little bit. There we go. Let's make sure it goes green to the bottom, but not green to the sides. Yes, so we have a little bit of stock to leave on the sidewall. And we want it to go green all the way around on these inner contours here. Now you will notice that I have a little bit of blue left over, and that's only because I didn't model in the radius into this part of the neck. It's just left square in my model, so it's leaving a little rounded corner. That's totally okay. I'm not worried about that. So we went green down to that surface, and do we go green on this one as well? Yes. And now, okay, so we have a lead in here that plunged into our model, so we're going to have to fix that. But right now, it is cleaning up that sidewall. So yes, it went green right here. So let's hit play real quick. That looks good. Let's take off the lead in on that last cleanup operation. Okay, and right click that final contour, edit. Go to our linking tab, uncheck lead in and uncheck lead out. Hit OK. Let's just simulate that one portion real quick. Just make sure we don't run into that again. Yes, we are good. We didn't plunge into our model this time. Okay, we are burning through this pretty quick. So that is already done on the truss rod side. Now there's one other thing you could do. So after you've glued up your material, so this actually is a section where the model itself has already been cut and glued. and now we're cutting the truss rod slot. But if you did notice that maybe your scarf joint overhung the face a little bit and you needed to flush those up, you could do a small facing operation to just clean up that entire face along that scarf joint. If that's what it ended up happening for you, then go ahead and add a facing operation in here. But for now, we're going to go ahead and move on. Let's name this truss slot overhang. And that one is now complete. Okay, so let's hide truss slot overhang. That's a hard word to say sometimes. And let's do neck roughing, show that, and let's go create new setup. This is where we're going to get into some really challenging toolpaths. So this is going to be probably the meat of the video right here. Okay, now that we're in our new setup, let's open up that folder. And let's go model is right here. And then we will do work orientation is selected point right here. Select our XY axes here and here. Flip our X just like always. Looks good. Our fixture is right here. And then our stock is from solid. And what we're going to do is we're going to bring in this cam stock one. Now remember when I was showing you guys this, I created a separate, completely solid body stock that didn't have two bodies. And there's going to be a very important reason for that, and I'll show you guys that in a moment. So we'll select that. In fact, actually, you can kind of see it's trying to create a boundary box here from the bottom up to the top. And then it's hard to see in this light, but it actually extends all the way out. And so it thinks the stock is significantly thicker in this area than it actually is. So we'll go into that in a second. Hit OK. And let's go ahead and create a contouring operation. And the main purpose of doing a contouring first here is only to give our 3D adaptive and scalloping toolpaths, or not scalloping, parallel toolpaths, a lot more room to work with, so that we can somewhat preemptively avoid some of those rapid collision to stock errors. Fusion 360 really likes to actually model from, or not model, machine from the outside in, as if like you're holding the part in a vise. And it's not really intended to cut a contour first and then machine, but the way we typically do things with guitars not guitars in general, but in woodworking and CNC routers is to kind of do it that way. And so we kind of have to work around the rules a little bit, and that's one way to do it. So let's go ahead and do 2D contour. And we need to find the sketch in here. So I've got this sketch that we can set up as our contour. So let's hold the Alt key. Let's hide our stock real quick so we can see this a little better. Hold the Alt key, and then we're going to select each individual piece. And the only reason I need to do that is because I have this as a closed selection, and I don't want to select a contour coming across here because that's going to cut into our model. So I only want to select these pieces here. And if you don't have this, then you just need to create a sketch and project in the faces of your model. So that way you can get access to the whole thing. And we need to make sure that our arrows are flipped over. So they have to be on this side of the line, not on the inside. So let's make sure everything's flipped to the outside. Got one here. Okay, that looks good. And then we can come into our, well, let's switch our tool back real quick, because right now we still have the 1/8 inch tool. So we need to go back to our 1/4 inch tool. So we'll go 1/4 inch flat end mill. Coolant is disabled, good. Avoid that error message. And then we will go to selection, the bottom of our fixture, or the top of our fixture. And this is going to get really tricky right here, and I will show you guys why I have to do this in a moment. So I'm going to not change my clearance height, and let's see what happens in a moment. And we'll go passes, multiple depths, and we're going to go 0.0625 inches. We don't need any stock to leave. And we don't, yes, we do want some finishing passes. So we're going to go 2 finishing passes of 0.125 inches. And that's to give ourselves a lot of little extra room. So let's go ahead and hit OK. Let's see what happens and see if it throws an error for us. Okay, so you can see already that it's generating way too many toolpaths because it's trying to go from the top of the stock. So we need to actually limit that down. So I'm going to show you what happens if you select the top of this right here. So let's go Edit, and let's go back to our heights. And then in the top height, let's go Selection, because right now it says Stock Top, but it thinks that stock is way up here. So let's bring back our cam stock, and we're going to select this top face as our top height. And let's hit OK. And let's see what happens. Simulate that. Might actually work. Okay, this might be a larger issue on the 3D adaptive, but sometimes what happens is Fusion does not like to machine at a lower height than the top of the model, right? So the clearance height, basically what happens is when you start your toolpath on your CNC, it's going to try to travel up to the clearance height and travel over and then come down to your retract height and then go down to your top height. And if your retract height is something significantly lower, in fact, that might be why it worked. So let's pull that up and check real quick. Let's go Edit, Heights. So it's coming from retract height, and this one says Stock Top. So let's change this to Selection of the top of our cam stock here and hit OK. Of course, this is probably still working again for us. It does look like it might be trying to cut in. Okay, so it is colliding with the stock. Let's see if we can pause that real quick. So it's not actually touching anything right now, but it's actually colliding with the stock. And that's because it's trying to rapid at this point, because as far as it knows, you don't have a model here, right? Because you put your clearance height as just slightly above this section, not the top section. And so what can end up happening is you end up generating a lot of errors in your toolpath if you don't set your clearance height up really high up here. Now that presents a really big problem for us because this is taller than my CNC Z height. And so if I set my clearance height here, the first thing my machine is going to do is travel up and crash at the top of my Z height. And I won't even get to my toolpath and I'll hit the E-stop. So what we'll probably have to do to avoid some of these errors is set our clearance height really high and then just go into our G-code when we post-process this, find any numbers that are at our Z height, or not our Z height, our clearance height, and change those values. So that way we can manually override this. Or you can deal with any of the collision errors if you'd like. Just pay really close attention to make sure it's not slamming into your fixture or into your model or anything like that. So the way we're going to solve this is we're going to go back to our contour and hit Edit. And then in the Heights tab, let's do this one by one. So let's check our bottom height. Our bottom height does need to be the bottom of the model. Our top height, we only really want it to start cutting at the top of this cam stock. And so we're fine with that. And then our feed height, so that is where the cutter stops doing a G0 rapid and starts applying our feed rate that we applied in our tool tab. So this 90 inches per minute. That is the point of where you will no longer get that error. So we need to make sure that our feed height is above the start of our cut up on this headstock in the contour. So let's go ahead and do from selection, and then we'll say from our highest point that we selected in our contour, which is this wing right here, and we will say like 0.5 above that. And then we will say our retract height is the same thing. So it's going to retract to where we know we are safe. So it's like a little safe zone both in the G0 rapid and in our retract. And then in the clearance height, we need to actually change this to the top of our stock, the actual top of our stock over here. So that way Fusion doesn't throw an error for us. And then we should be able to run the simulation without any errors. And then we'll have to go back in once we've posted these and edit out these, edit the G code. Now, you won't have to do this if you have the adequate Z clearance for your machine. In my particular case, I don't. But the top of this neck, or the top of this headstock is about 2.5 inches for me. That's taller than my Z clearance, so this is what I have to do. So let's just go ahead and hit OK, and let's try simulating this and see if we get any other errors. So right click, simulate. Let's hide the cam stock and run it through. Okay, so we were able to get rid of those errors. So we're going to end up applying that same technique to all of the other toolpaths we're going to do in this setup. One last thing I forgot to do in the contour. So let's go back to edit real quick. And let's go to geometry. We're going to add tabs to just the heel side, because right now we are securing down the blank with double-sided tape, which is fine for this operation. The reason we're going to put in tabs is that once we take this off the blank, or sorry, off the fixture, and we put it onto our 3D printed wedge, we don't want this to be loose and be able to dangle inside of our stock. So we actually still need our heel to be secured to our stock for the next operation. So what we're going to do is we're going to turn on tabs, and then we will go at points, and we're going to say at this point, and let's rotate the other model over, and we'll say at this point. Now I am using my sketch selection still, the one that I did for my contour to develop this. When I had that turned off, it didn't allow me to select these points on the heel. And then I'll say from here, here, and here, and let's make all of these like, well, that can stay 0.0625, but our tab width, we're going to go ahead and make 0.75. Something pretty meaty, so that way it's very unlikely for this to actually snap off. And let's go ahead and hit OK. And we'll simulate one last time, and then we'll move on. Okay, let's just make sure the tabs show up the way we expect, and let's hide our fixture. Make sure we go all the way through with our tabs. Yes, we are good. Let's check the bottom side. Yes. Okay, that's looking good. We're green on all sides of the contour, and we have our tabs, and we were able to avoid those clearance issues. So now let's close out of the simulation, and let's do our big 3D adaptive to clear out most of the material on the neck. So we will go 3D adaptive, clearing, and then we want our 1/4 inch flat still, so we're good there. And in the geometry tab, we're only going to machine up to, here, let me close out of this real quick. We're only going to machine these surfaces and the heel. We're not going to go into the headstock transition, because what will happen later is as we flip the part up on this angle, that's going to really complicate our selections and what we're able to machine and clean up this surface. So we actually want to machine this entire surface of the transition from this angled view. And that's because that's at the point where we have access to all of that geometry. And we don't want to end up really cutting that twice. Because if we end up cutting that section twice, we might end up with little errors or misalignment issues, things like that. So we're going to cut this transition on the angled face, and we're going to cut everything else in this orientation. So let's go back to 3D adaptive clearing, and we've still got our tool and stock contours. I've got a selection or a sketch here that basically starts from that point. And so this is the area that we're going to be machining. And then let's turn off rest machining and check model. We want to make sure that it's not trying to machine anything else. So we're going to say we want to select all of the surfaces on the top of our model right here. And we don't want to select any of these contours because those ones are already green. Those are already solved from the contour. And then our machining boundary will be selection. We're going to use the exact same selection, and tool can go outside of boundary. That's just fine. We might need to add an additional offset, but let's see in a moment. And then in the geometry tab, we're going to do the same thing we did before, except in this case, there is no feed height. So our retract height needs to be our feed height, essentially. So we're going to say the bottom needs to go to the model bottom, which is totally fine. And then our top height needs to be from selection, not stock top, because remember our stock top is technically up here. So let's bring back our cam stock, and our top height is going to be the top of this area right here. And then our retract height is going to be from selection. Let's hide our cam stock, and let's go from right here and do the same thing we did before, 0.5 above that. And then you might not need to go that high in this particular case because we're not machining anything over here, but we already know from the previous operation that that's a pretty safe value. And then let's go clearance height is from our top of our cam stock, and we'll say 0. That turned this back to black because it didn't like that the clearance height was lower than the retract height. So that should be good. Let's double check this again. So we are going from, bring back our model. I think I selected the wrong thing. We want to go from here to 0.5. There we go. That looks a little better. And then in the passes tab, what we want to do is we want to go to both ways, keep our optimal load at 0.1. That's fine. And then we will do our maximum roughing step down of 1/16 of an inch so that each layer that we're going to leave for our ball nose end mill will be 1/16 inch deep. And then we will we'll definitely leave stock to leave. And let's go ahead and say order by depth. That might be unnecessary, but that will allow our tool to stay in a concentrated area based on the depth that we're currently at. And then let me just double check. Do we have anything else we need? Let's go to our linking tab and scroll down. Let's take off any lead in or lead out transition, and let's assign at least one entry position. So that way we can make sure as much as possible that we're not starting in an area that we don't want it to machine, like the transition. So we'll say from that point right there. We can also say if it lets us, sometimes the selections here kind of suck. And then we'll say like right here, and right here. So those are the areas that the program is technically allowed to enter the stock from, but there are certain circumstances where it no longer is going to be cutting that area and it's going to come in down on the side. And so we still might run into some issues, but let's hit OK and see what happens. Might take a second to generate. Okay, so let's simulate this. Let's see if we have any errors. We still do, so we might not have perfectly solved that, but let's go ahead and hit play. Let's make sure we have stop on collision checked. So it's going to go through that contour, and then it's going to enter in from that first spot that we designated and start clearing out material. Do the first layer, same thing on the second layer. Keep going, whittling away this material. And then our first one is over here. So let's back that up just a little bit and play it pretty slowly, and let's make sure that what's happening is something we're okay with, because we've already set up our clearance heights, etc., and we won't really get another opportunity to solve some of these in this particular type of model. So as long as we're okay with what the cutter's happening, so I'm typically okay if it's plunging into the material like that, but what I don't like is if it's side loading the cutter. If it's side loading the cutter really hard, that can cause my CNC to lose steps and I'll need to find a different solution. So let's slow it down and hit play. Okay, it's coming in here. Let's see what this is going to do. I'm going to turn off stop on collision and slow this down. Okay. So you can see it's still not touching anything, but that's because we don't have a feed height. So we're still getting an error of rapid collision into stock. But let's see, it's just going to plunge down. And I'm actually okay with that because my cutter or my CNC can handle plunging. What it can't handle is major side loading of the bit, because then it can cause it to lose steps. So let's just check each one of these as we're going through and make sure that's what's going to be happening in the cut. Otherwise, we might need to change something. Okay, we've got this one, which looks like it's going to be the same. Oh, we teleported to the other one. Okay, it's going to come in here in a second. Okay, just double check this. Yes, that one's plunging as well. We're okay with that. And then we'll check this one as well. So it's going to retract up, come back down. Nope, we didn't hit that yet. That's further forward. Okay. Yes, it's going to plunge there again. So let's go to this one. If you didn't know, you can zoom in on the timeline here if you just scroll while your mouse is over it. And that's actually quite helpful for getting in on some of these longer operations. Yes, that one is plunging as well. Let's check this one. That one is as well. I think that's going to be the same for all of these. So let's just check again. We're almost done here. It does look like I messed up on my step over. Yeah, that one was plunging as well. The step over here looks like it's trying to apply a fine step over on some of these shallow areas. So I probably forgot to make my fine step over the same as my large step over. So we'll have to take care of that in a second. And let's check this one last one, and then we'll make that adjustment and simulate. Same thing, but this one, look, it's just barely clipping that material. It's totally okay. And let's run it through the rest of this real quick. That's looking pretty good to me. So let's zoom up and make sure that everything that we want touched is touched before we go back in and make our changes. So we didn't touch these outer walls. We're good there. We look at this. Our tool was allowed to go outside of this boundary. So that way we left a clean surface here for our ball nose end mill. But we're not actually still cutting into our model at this point. So that's totally material we were going to end up removing anyway. So we're fine that this went outside the boundary a little bit. So that looks good. So what we're going to do is we're going to right click and change our step over. So adaptive edit, and then go into our passes tab. And so our maximum roughing step over is 0.0625, but our fine step down is 0.00625. So we just need to make those the same, hit OK. This should load significantly quicker now because there's so many less toolpaths. Yes. And let's go ahead and hit simulate one last time. Just run it through and double check. There's our errors. Okay, So that's looking more like what I was expecting. These ridges here are significantly taller, and we cleared out all the material that we need to, and so I think we're good to move on to our ball nose parallel path. So let's close this out. Actually, before we move on to the ball nose, one thing we forgot to do was clean up this face, because we did leave stock to leave on this face. So let's do a 2D facing operation while we still have our 1/4 inch flat end mill. And then in our geometry tab, we're going to select this contour right here. And then in the heights, we're going to say, instead of model bottom, we're going to go to that surface right there. And then our top height is going to be the same cam stock top. And then in this case, we have a feed height as well. And so we will go selection, again, the highest section that may or may not be machined. And we'll do 0.5 as our feed height there. Retract height is going to be the same as from this selection plus 0.5. And then our clearance height. So selection is going to be from the top of that stock. So right there, and we'll make that 0. And then in passes, it typically orients in a horizontal fashion. So let's go ahead and switch it to 90 degrees. So pass direction will switch to 90. And then we will apply a extension of 0.125, actually 0.0625. So that way it cleans up this tiny little area right there. And our step over, let's go ahead and make 0.125, so half of our bit. No multiple depths, no stock to leave. Let's check that real quick. And so we'll just simulate that operation. Let's hide our cam stock. Okay. And let's make sure that it's not going to hit that side wall here. So let's watch this cutter as it comes through. Okay, we're good. We probably could have applied a little bit longer of an offset, so if this doesn't clean up very nicely, we might be able to do that. Coming through. Okay, so we do have a little bit. I don't know if we're going to be able to get all of that, but we have a little bit more breathing room here because we applied finishing passes on the contour. So let's make that offset just a little bit larger. So let's go 0.125, and let's make sure that our bit doesn't end up crashing. So simulate. Okay, and let's slow it down in this corner, make sure we're okay. Yes, we're okay. It didn't hit the sidewall. So let's see what that corner ends up looking like. Okay, I'm okay with that. There's a tiny little piece there, and that's going to end up getting cut off by the ball nose end mill anyway, but we don't have a giant, piece that was unmachined. So that looks good to me. Let's go ahead and move on to the ball nose end mill. So let's set up a 3D parallel pass, and we're going to change our tool to our 1/4 inch ball end mill. And then we're going to go to Geometry tab, and our machining boundary is going to be that same selection that we did for the roughing. So we're only cutting this part of the neck, not the transition. And then we are going to say avoid touch surfaces. And what this allows you to do is say you can machine everything within this boundary except these surfaces. The toolpath has to work around them. Or what you could do is you could select touch surfaces and say, well, within this boundary, it has to touch these surfaces. So you can have either or. So we're going to say avoid, and we're going to avoid all the areas on the neck pocket. So like that. Make sure we have this face not touched because that's already done as well. And that looks pretty good. So we want to make sure the tool is on center boundary. So if it's outside the boundary, it's going to have the same limitations as the roughing one earlier. But we actually don't care about that. What we care about is that the cutter is cutting everything that's within this boundary, but is also allowed to go just outside of it. Excuse me. Is allowed to go just outside of it down on this bottom corner here. So we're going to turn on contact point boundary. And what that does is that allows the tool to extend past the boundary line so long as it still has material to cut. So we're going to go ahead and do that. and hit OK. If you don't do that, what ends up happening is sometimes you get a little flat spot on the bottom here. And then in our Heights tab, we're going to apply the same thing we did before. So exact same thing here. Top height is going to be the top of our stock. So let's bring back our cam stock right there. And then our retract height selection, let's hide this, is from here plus 0.5. And our clearance height selection is from the top of here and no additional offset. And then in the passes tab, we want our step over to be pretty fine. So we're going to do 32nd of an inch. In this case, I learned from the last episode that I don't need to change the pass direction. And I don't think we'll need to change any of these here. So let's go ahead and hit OK and see what happens. I didn't disable coolant, so let's do that. Hit OK, let it generate. And then we'll just simulate the adaptive and that one. Let's hide the cam stock and simulate. Okay. So, I had the facing operation. The roughing one was already done. Okay, so we did get one error right at the beginning. Everything else looks pretty good. Let's just double check. And let's look at our boundary here. So yes, our sketch is right here. Everything on this side of that boundary was machined. Everything on this side just kind of got clipped, but that will get taken care of later. Just make sure we don't run into any other issues. And we'll look at that error at the beginning. Yep, it did clean off that little piece left over from the facing operations. So we are good on this side. Let's just go back to the beginning to that little piece right here. And let's say stop on collision right here. And what is this? What is happening here? Rapid collision with stock. So let's zoom in a little bit. Bring it right before it. Still had it way too fast. Okay. I don't know why that one's triggering. That one looks perfect to me. So let's speed this up. Turn it off of stop on collision. Okay. I think that's fine. That's doing exactly what we want it to do, but it's detecting that some part of the stock it's colliding with. But looking at how the end mill is interacting with the material, I think that's totally safe, and I'm fine with that. Yeah. Okay, we're going to leave that be, and now we're going to move on to our last setup, and then we'll be able to be done. Okay, so setting up for the final operations, let's go ahead and create a new setup. And in here, we're only going to select this part of the scarf joint, because everything that we're machining that's up on this area right here has basically mostly been machined already. So let's go to our stock, and we'll do from solid. And then in here, let's bring up our operation 5. And we want to select this as our stock right here. This will help us avoid a really, really tall clearance height. Now, the other one is already really bad, but in this case, it's even worse because we've angled it up this way. So, and I'll show you that in a minute. But let's go to stock point to model box point. Right. Let's go to this front corner right here. Or sorry, selected point right there. Select X and Y axes here and here, and then flip our X axis. So we're good there. Our model is going to be this right there. And then our fixture is this and our 3D printed wedge. So let's go ahead and hit OK. That should be good. And then we'll set up for a 2D contouring to come in and clean up this side of the transition, because we already did cut this contour right here, but what that didn't hit was this flat spot right here. So we need to go ahead and just run another contouring operation, which will also have the added benefit of giving us more room for our 3D adaptives to come in and work with. So let's do 2D contour. And then what we will select as a geometry, let's see if we can, so we're going to go up to this line right here. So we should be able to select everything going around. So we need to switch our tool back to our 1/4 inch flat. And then in the geometry tab, hold the Alt key, and we're going to select everything going around up until that point. So turn our model around. There we go. And right here, and right here. Let's make sure all the arrows are on the correct side. It looks like they are. Okay, we don't need any stock contours or anything like that. We do want tabs for the same reason as before, is because this has been cleared out. And we are going to be holding on to our stock with shoulder bolts here, but we're not going to really be able to hold on to the model itself once we cut through this. We will be able to hold on to the front face with blue-sided tape if you'd like. In this case, I'm just going to opt to use tabs. So let's go at points, and we'll say here and here. And then we will say here and here. And let's make those 0.75 wide. Let's make those a little bit taller. There we go. Again, we can always pare these away with a chisel or anything. And then in the heights tab, because we selected our stock that doesn't extend way up here, we don't really have to do the same trick anymore. So let's do top height is stock top. That's fine. Our feed height, in fact, I think we can leave all of these the same. We might have to check that in a minute. And then in the passes tab, we want multiple depths of 0.065 because our bit is going to be plunging all the way around. And then we want 2 finishing passes of 0.125 wide. And then in our linking, we're going to turn off any lead in or lead out because we're just going to plunge down a 1/16 of an inch and start cutting. That should work. So let's check that real quick. Now I wanted to show you guys the material that is still left over that isn't within this stock. It's pretty minor, and so I don't think it's going to be an issue for this contouring operation. So let's see if I can pull up this one right here. And let's just click on our stock. So this right here, this yellow portion is the stock that we selected. This is the stock that kind of overhangs some of that. And this is the point of which we machined in the previous setup. So if you extended this line up to right here, there's just a tiny little wedge here that it has remained unmachined from that previous one. But the added benefit of not having to go through all of these clearance and just plunge through like an extra 1/16 inch of material just on this side right here, I think is well worth it. So I'm okay with that, but we can simulate it if we'd like. But let's go ahead and do our 3D adaptives, and then we'll come in and clean everything up. So let's do 3D adaptive clearing. And then let's make sure we still have our 1/4 inch flat. We're good there. And then machining boundary is going to be selection. And we're going to select both of these contours right here because we want it to machine everything that's within here as well because there is material left over from the previous op. And then no stock, actually no, we do want stock contours. So we're going to select the exact same thing. Hold on. Sorry about that. I didn't mean to hit escape. 1/4 inch flat. Machining boundary is these two, and our stock contours are those same two. And then turn off rest machining. And then in model, we're going to select the faces that we want it to cut with this, but not these side faces because we just did a contouring operation there. So we're going to select the transition and these top faces right here. And include setup model is fine to leave on because that will help us detect these holes. And then we can say our bottom height is model bottom, so that's good there. Our top height is going to be the top of the stock that we selected. Our retract height, let's give ourselves a little bit more room on top of that. And our clearance height will be the same as our retract height. So we can go from retract height 0. So that way they'll be the same. And then in the passes tab, we want to machine both ways with a 0.1 optimal load in both directions. And then we want to set our maximum roughing step down and our fine step down, like we did before, to 0.0625. And then we do want stock to leave, because we're going to come back in with that same flat end mill trick that we did in the last video. And then in linking, there's no lead in, lead outs, but we can turn these to 0. That should be okay. We did get an error, so let's see what happens. Okay, Z clearance is too low for the surface. So that tells me that we still have a problem with that clearance that we set up. And that is likely due to the fact that the model is extending far beyond our stock. And again, Fusion doesn't like to have clearances or anything that is not above the model. So contrary to what I said earlier, I think we are going to have to go back in and make that extremely high clearance height, and we're just going to have to edit it out in the G code. So let's do clearance height from selection, and let's bring back our heel side of the stock to right here. And then our retract height should be able to stay the same. Let's find out. Yes, it is generating now, so you can tell that that immediately solved the problem. We needed our clearance height to be above the model. And because our model went all the way up here, that we are kind of pushing the boundaries here of what Fusion finds acceptable types of machining. Because most machines that we're going to be performing this type of stuff on is like a big 5-axis machine. And they won't have those Z clearance problems. And so a professional machining center, they won't need to go through all this extra work. We're just having to do that to force our machine, or force Fusion to work with this on our limited Z height little X carve that I've got. So let's simulate these two, make sure we don't run into any problems before we move on to cleaning everything up. So let's hide that heel scarf. Okay, so we're doing our contour first. We do have another error of rapid collision with stock. So we might not have put enough of a boundary there. So we'll check that. Let's go through the contour, make sure it leaves the tabs. Yes, it did leave the tabs, so we're good there. Okay, and let's make sure that everything's okay with the clearing. So it is important to remember that right at the beginning of this clearing, it's going to be plunging a little bit extra. So it's going to be going like 1/8 of an inch plunge at this point, because we have that little wedge sticking over. Okay, stop on collision. So let's zoom in on this real quick, make sure that's okay, and see if we actually need to come back in and change it. Okay, it's just going to plunge, so I'm okay with that. Yep, it's just going to plunge down and then keep going. I'm okay with that. Let's zoom out and go to this one, double check the same thing. Should be plunging again, just like before. Yes, I'm okay with that. And let's just check all of these real quick. I apologize. This is the nature of doing this kind of machining. It's going to plunge as well, so I have a feeling that's going to do the same thing for the rest of these. Let's just check the location of each one of these. If it's in the same location, we'll assume it's doing the same thing. Yes, it's just moving further out. So that's okay. Let's speed it up. Okay, so let's show our model. Well, I guess it's already showing. So this should be on the same area of the boundary. Now we left stock to leave, and so remember, these might not actually even be plunging or touching anything. It might just be doing that simply because we were simulating a part of the process that's not outside of the context of the previous operation. And so we might actually, these plunges might even be less severe than what we're looking at here. So I'm not terribly worried about it. So now we're going to clean up the top side or this back side of the headstock, and then we will switch to a ball nose end mill to do our final operation. So let's go to 3D parallel. We've still got our 1/4 inch flat, so we are good there. And then in our boundary, machining boundary, we're going to select this back contour right here. And then we're going to choose these surfaces that we're going to be machining and leaving include setup model checked. And I have a suspicion that it's going to try to go into these holes. So we'll take a look at that in a second, and I can show you how to compensate for that. Tool on center on boundary. So we're good there. And again, we're going to have to do our little trick as we found out. So stock top is fine here, but our retract height is going to be from stock top 0.5, and our clearance height is going to be from the top of this heel stock at 0. Again, it's really annoying, but because of how this is interacting with our Z height, we have to deal with this. So then in our passes, we're going to do pass direction as 90 degrees, because if I don't do that, it's going to go this way, but we want our parallel to be going this way. Let's hide that heel side. And then our step over is going to be 0.03125, so a really fine little step over. And that should be good. Let's hit play or OK and see what happens. Okay, yes, so it is trying to jump into these holes here, and those have already been machined in like our very first setup operation. So we need this to pass over those. And for some reason, when I was developing this, I couldn't get it to pass over those, and I had to go find a solution for this, and I wanted to share kind of with the class of what's a really neat trick you can use for this. So in slope, what this allows you to define is what is the minimum and maximum angle on your model that it will detect and machine. And so, for example, we have an angle here that's about 45 degrees roughly from our bottom surface here. So if you drew a line up, but we don't want it to machine anything that's 90 degrees. And that's what these holes represent. They represent a 90-degree change in direction of our cutter. So we can say from slope angle, we're allowing it to machine from 0 to like, let's say 60 degrees. We won't let it go like beyond 90 or anything like that. In fact, let's do something smaller and see if it doesn't touch this front surface. You can see it left a little section where it's detecting that, oh, it can't cut that because of the slope angle. So let's go back to edit. And let's change this to 60 degrees. Hit OK. And yes, now it's actually machining everything, and it's passing over these holes. And that's exactly what we want. In fact, it kind of looks like it's going over our volute a little bit. Let's pull up our model and then go back to the setup. Back to model. Actually, no, it's not. It just looks like that because of the stock to leave. So let's simulate this real quick. Make sure we're okay, and then we will do our final ball and mill cleanup. We still have those errors from the previous one that we're okay with. The last operation that we just put in, there's no errors, so we are good there. And let's zoom through this contour and then clearing out the material. Turn off stop on collision. And then, yes, it's coming in and cleaning up that area. Let's slow it down. And yes, it is just simply passing over those holes, which is perfect. It's not trying to enter in. So we can speed that up. And now we've cleaned up that backside. Now all we need to do is just switch over to our ball end mill and do another parallel pass on this surface right here. And then we'll be done. Okay, so let's go to 3D parallel. And let's switch over to our 1/4 inch ball end mill. And then what we'll do is it looks like our feeds and speeds are a bit wrong. So 16,000 RPM, and we'll do 75 inches per minute. And then go to our geometry tab, and machining boundary will be selection. Now we can either select each side of these, which may cause problems. We'll have to take a look. Or we can do silhouette, which will basically create a line around the entire model. So let's try it this way. And then we will do avoid touch surfaces, and we're going to check touch. Because with this machining boundary, it will basically try to detect all of this as well. And we want to say, no, we only want it to touch these two surfaces. Okay, and then selection, we will select for machining boundary. We will select these two, and let's see if that works. If it doesn't, we might try silhouette or something. And that should be good. And then model bottom is the fixture. Our top height is the top of our stock. So let's bring back our stock here, the headstock side. And then we do retract from stock top 0.5. And our clearance height, again, is our top of this right there. And let's make that 0. And then in passes, we do want it to stay going in this direction rather than 90 degrees like we did on the previous op. So we'll leave that be, but we want our step over to be 0.03125 inches. And that should work. If not, we might have to change our machining boundary. So let's see what happens. Okay, it looks like we're not hitting everything. So we're only getting about halfway down. So let's try changing our machining boundary to silhouette, which basically projects the entire body surface onto the machining toolpath. And let's see if that solves it for us. Nope. So let's go back and hit edit. And let's turn on contact point boundary, because right now it's trying to stay within that boundary that it's projecting, but we're not allowing it to go slightly outside to make sure that it touches some of these areas. Hit OK. There we go. That's looking a little bit better. So we're actually reaching this full extent of this wing here. So let's right click and hit simulate. And let's see what we got. Okay, we have some tool collides with fixture. We'll need to take a look at that as well. Tool collides with fixture. Yep. Okay, I have a feeling I know where that's coming from. So we'll take a look at that in a second. Okay, bringing out most of the material. And then we're going to do our cleanup on the back side of the headstock. And turn on stop on collision, and let's take a look real quick. Okay, and this is a tool collides with fixture. So that means that you can see here the little channel that I put here didn't take into account this little part of the neck. And so it's actually crashing into that, and it might crash into it right here as well. I will go ahead and update that later on, but basically what you guys will need to do if you want to avoid that, unless you're fine with the tool actually plunging into that a little bit, it doesn't go very far. It only goes like maybe like a 32nd of an inch or something. It's not a huge deal. But basically you'd have to provide a little bit of clearance like I did with this slot here for that tool. And yep, same thing on each side. And then it works its way through because now it's got the clearance. And then this is a tool collides with fixture again, because it's going all the way down to the bottom. Yep. So that's all I would need to do to resolve these, is create an extra little channel around for this flipped operation, and we would be fine. So let's just make sure all surfaces are green. It does look like we have a little bit of a challenge here, so we might need to come back in and resolve that. Let's play through the rest of this. Turn off stop on collision. Okay, So we have a little flat spot here, and we have a little flat spot here. So let's see if we can resolve that real quick. So the first thing we're going to try is right-clicking and do Edit. And then in the Passes tab, we'll try machining steep areas. Because what this allows to do is it allows this toolpath to have a varying degree of step over depending on how steep of an area it's attempting to machine. So we can say the absolute minimum that we will allow it to have. Right now it's 0.003, so just like 0.003 of an inch. Let's make that 0.005. That'll be the absolute minimum. And then the maximum will be the one we set before. And let's see if that resolves it. So you can see in these areas, it's going to take more passes. It looks like it might still be leaving a little flat spot there. So let's just simulate that and double check. Okay. Yep, it's still leaving a flat spot there, so I'm not sure how well we'll be able to adjust this, but let me try. Okay, so I spent a little bit of time working on this, and I was able to get it to clean up most of that surface, although there's still a tiny little section here that I just can't seem to figure out no matter what options I choose. So I'm going to have to, at least in my model, deal with that and just sand it out. But let me show you what I did instead. So if I go back to Edit on the parallel, and I go back to my Geometry tab, let's bring back our model here. What I did was I flipped my Avoid Touch Surfaces and used Model Selection. So I said I want to machine these surfaces, and I included the setup model, so that way it's not trying to machine the other surfaces or machine over it. And then on Avoid Touch Surfaces, instead of using Touch to touch these ones, I selected Avoid and selected everything else outside of that. What that allowed me to do is basically allows my tool path to continue all the way over to the edge, whereas the way I had it selected before is just the way the programming works. It wasn't liking it very well. And then I tried doing machine steep areas. It didn't really help, so I'm not going to apply that. And if I hit OK and we simulate the whole thing, you'll see what we're left with. It's not perfect, but it's pretty dang good and very easy to sand out. Again, these errors that we have right here are ones that we've already tested and are okay with. And these ones are tool collides with fixture, and we know how to solve that. So we did the contour, then the roughing, and now we're cleaning up the back of the headstock. And then we are cleaning up this, and it goes all the way to the edge, which is great, but it leaves a tiny little flat spot right here. And that should be, I mean, what you're seeing here is a couple thousandths of an inch, so it's not a big deal. We should be able to easily sand those out without much trouble. So I'm okay with that. But if in your model, if you just want it dead on perfect right off the CNC, you might have to play around with the options some more. I wasn't able to solve that, at least in my particular model. So, in summary, we processed our stock, cleaned up our scarf joint, cut the truss slot, and then flipped it over and machined the primary surfaces, and then flipped it over one last time and cleaned up the headstock. All on a CNC with a limited Z clearance and a low-cost fixture with just a 3D print to help us along the way. We had to do some workarounds with our clearance heights to allow Fusion to generate the toolpaths, but ultimately we came out with solid toolpaths and a nearly perfect model. I do want to stress here that we are somewhat pushing the boundaries of what Fusion finds acceptable machining methods. Most companies that would produce these parts full-time would invest in larger machines and more robust fixtures to make this process more bulletproof, and Fusion CAM is primarily targeted towards those applications. However, I am confident that this process we produce today can allow just about anyone with a CNC to produce a good part. There is always room for improvement, however, so if you have any suggestions, I would love to hear from you down in the comments. If you'd like to support my channel, or would like to download this project file, including the fixture, toolpaths, and even the animation at the beginning of the video, you can find me on patreon.com/Austin Shaner. If you have any questions regarding this process or would like to submit a request for my channel, you can send me an email or join our Discord server to get help from myself or other viewers on projects you are working on. Links will be in the description below. That's about all I have for today, so thank you so much for coming and sticking with me through this hour and a half. This is Austin, signing out.